Exponential and logarithmic graphs. An exponential function is of the form y equals b to the x, where b is a positive real number. For example, let's look at y equals 2 to the x. And let's make a plot of it. We can do a simple t-chart, x versus y. And I'm going to start at x equals 0, but I'll put it down here a little bit. So when x equals 0, y equals 1. Anything to the 0 power is 1. So my graph will go through the point 0, 1. When x equals 1, y is 2 to the first, or 2. When x is 2, y is 2 squared, or 4. When x is 3, y is 2 cubed, or 8. So every time x increases by 1, y doubles. So sometimes I think of exponentials in terms of like doubling functions or tripling functions or other things like that. Well, how about on the other side? What about when x is negative 1? Well, y is 2 to the negative 1. And as you recall, a negative exponent simply flips my base, where 2 is my base, flips it upside down. If the 2 is in the numerator, 2 to the negative 1 would go into the denominator. If it was 1 over 2 to the negative 1, then that 2 would flip up to the top. But this should make sense, because if I'm doubling when I'm increasing by 1, then I should be cut in half when I decrease by 1. And notice that as x gets very large negative, y never equals 0. It gets really close to 0, but it never equals 0. Now this is the basic shape of an increasing exponential function. Sometimes we say exponential growth. Let's talk briefly about the domain and range. Big D for domain. Well, x can be anything. X is an element of the reals, or if you want, it's anything. Negative infinity to infinity. But the range here is strictly positive y's. Y is always bigger than 0. Okay, well, what if we had an exponential function but where the base is a fraction between 0 and 1. So in this case, my base b is a half. Again, we can do a t-chart. I'm going to start at 0. So 1/2 to the 0, anything to 0 is always 1. And then as x increases by 1, y gets cut in half. It's a 1/2ing function, if you would. And as x goes backwards, instead of being cut in half, you're going to double. I'll put that one down here. So 1/2 to the negative 1. Remember that the negative exponent flips things upside down. And so we get something similar to the first graph, except that the graph is decreasing. So you have one of these two basic graphs for exponential, either the increasing function or the decreasing function. Looking at the domain and range, those didn't change. X can be anything. I can plug in any number for X and get an answer out. But the answers that I get out, my range, are strictly positive. Now, I'm not going to get into depth about transformations because once you understand how one function gets transformed, you understand how they all do. But what if I had y equals 3 times 2 to the x? Just very briefly, in PEMDAS, you do the exponent first before multiplication. And if I understand transformations, then I don't need to plot points so much as compare this to my original function. That is the first example I did. Because I have 3 times my original function. So if the original function was at 0, 1, this would be 3 times that. And the next one was at 1, 2. Then this one will be at 1, 6. And then I could continue doing things like that. But just to show you one really quick transformation. If you understand transformations, you understand what's going to happen here, even if I did something like this. Like if I did 2 to the x minus 1. We don't usually write it in parentheses, but I'm going to write it like that to show you that 2 to the x minus 1 has implied parentheses. And you should know how things move when we put things inside parentheses. If you're unsure, go back and watch the transformation video. It's not too difficult. But let's talk really briefly about logarithmic graphs. And so a logarithm is the inverse of an exponential function. And we usually just say log instead of logarithm because logarithm takes a while to say. And a log function is often written like this. Y equals log base b of x. And so we often don't put parentheses here in mathematics, but you need to know that there are implied parentheses right there. So it is the log base b of x. It is not log times x. You need to think of the log function as being like the function, like f of, log of, f of. It's not log times, it's not f times, it's log evaluated at x. So if I have y equals 2 to the x and y equals log base 2 of x, these functions are inverses of each other. Now, how does that help me graph a logarithm? Well, let's do a new exponential function. Let's do y equals 3 to the x, which I would think of as a tripling function. Its equivalent inverse is y equals log base 3 of x. Now, I really want to graph the log function, but I'm going to start by graphing the exponential function. So it goes to the 0, 1, and then it triples every time I increase my x by 1. I think I have my points correct here. And it gets cut in a third as I go backwards. I missed the point. Let me try it one more time. All right, it's a little bit better. So here is y equals 3 to the x. And I'm going to put the points down here. So it goes through 0, 1. And it goes through 1, 3. And it goes through 2, 9. And then I'll put one of the negative ones. It goes through -1, 1/3. Its domain is all real numbers. Its range is only positive y values. Now, how do I get the logarithmic graph? If you recall, when we find inverse functions, one of the first things we can do is switch the x's and the y's. So for example, 0, 1 becomes 1, 0. 1, 3 becomes 3, 1. 2, 9 becomes 9, 2. Like that. -1, 1/3 becomes 1/3 -1. And notice that we have a horizontal asymptote of my graph going this direction. That is for my exponential function. And my logarithmic graph will have a vertical asymptote. So whereas the exponential y never equals 0, it's always positive. For my logarithmic graph, x never equals 0, it's always positive. So I'll plot some of these points, I'll put them in for you. This is my logarithmic graph, where I switch the x's and the y's. Which means I can essentially switch the domain and the range as well. So for the domain of my exponential function, it's all real numbers, which means the range of my log function is going to be all real numbers. The range of the exponential is positive y's, which means the domain of the logarithmic will be positive x's.